Yes, good morning, everyone. How are you people?
Good morning, ma'am.
Good morning, ma'am. Fine, ma'am.
Ma'am, yesterday PPT upload
Yes,
చేస్తానన్నారు కదా.
okay. Uh, you didn't see in YouTube? I have shared the link over there. If you go for yesterday's topic, you would have find it out YouTube.
Okay, no, just now they posted some YouTube links in Telegram, ma'am.
Yes. Okay.
Okay. Okay.
Okay, fine. Okay, so what did we discuss in last class? In yesterday's class, I have explained all the operations which we can perform on sets. Okay, not only the mathematical operations, there are other operations which can be performed on sets. Okay, so these are all the operations which will be performed along with the mathematical operations. Okay, first one is update, second one is add, remove, okay, discard, pop, clear, length, X in S, that is in operation, not in operation, subset, okay, is superset, union, intersection update, okay, difference underscore update, symmetric underscore difference, copy is disjoint, okay, and these are some of the methods which we'll be using. Okay, first one is all, second one any, next one is enumerate, max, min, sum, sorted, S is equivalent to T and S is not equivalent to T. That is, if the two sets are equivalent to each other, what is the resultant we'll be getting? And if both the sets are not equivalent to each other, what is the resultant we'll be getting? Okay, so these are the operations which we have, which I have explained to you in the last session, Nana. Okay, you people have any doubts regarding the last topic? Because here we'll be closing the sets and we'll be going to uh, frozen set and set comprehension. You have any doubt regarding to these operations which are performed on sets? Yes,
Ma'am,
guys.
can please explain again?
Again, all these operations. Okay, you just
Uh,
do one thing. You said that you have found the link, you have got the link on Telegram, right? You just
yes,
go
ma'am.
through that video, which I have explained to you yesterday. If you have any doubts regarding those operations, we shall discuss it. Okay? We have lab afternoon, right? If possible, we'll be discussing at that time. Is it okay?
Okay.
Okay? Yeah. So, shall I go to the next topic? Yes, still any student has to be joined because yesterday some students has been missed the classes saying that they didn't have information about class. Yes, is today's strength this much only? 36 participants are there. That is 35. Is it so? Where are rest of the students? Vinay?
Yes, ma'am.
Yes, are rest of the students joining the class, or shall I start the class now?
Ma'am, just 1 minute, ma'am. I'll be informing them.
Okay, because yesterday also you people have missed the class and there were a lot of absentees. I don't want to continue in this way.
Ma'am, today we'll do lab number what?
Yes, week 4, Nana.
Okay, ma'am.
Anvesh, yesterday's class you have listened?
No, ma'am, there was network issue, ma'am, in our area, or else I'm not audible.
I wasn't audible or you weren't.
Ma'am, I mean, Your voice is breaking, ma'am, at that time.
Okay, see,
But
I'll
I was
listen,
Just
everyone. I'll just give the brief explanation about all the operations. Okay, is it okay?
okay.
So that you'll get the idea about it. Okay, see, yesterday I have discussed these set methods with you people, but as you are saying that you weren't having a clear idea about it, I'll just explain them again briefly. Okay, so what does update do generally? What, why we'll be using this particular operation? See, whenever you want to add element to a particular set, okay, so we can use this update. That is nothing but if we are having a particular set and you want to update it with other elements of another set, then you can use this one. Okay. And here is the example which shows how you can update a particular set. S here, S is equal to set of 1, 2, 3, 4, 5. E is the another sound. I want to add that is nothing but the set should not contain duplicate elements. We need to avoid it. Okay. So
ma'am,
with
your
that,
voice is breaking, ma'am.
I have written this now also. Is it okay now? Am I audible?
Yes, ma'am. Now it's
Okay, fine. See, okay, first one is update Nana. Whenever you want to add elements of one set into the another, okay, without duplicates, then you will be using this update operation. Okay. And here in this slide, every operation is being explained with example code and its output. Okay. You please go through it and let me know if you have any doubts. Okay. Concentrate. Next operation we are having is add. So what is the difference between update and add, Nana?
Add with add we can add only one element, ma'am.
Yes. Okay. So add element X. If I want to add a particular element X to the set S provided, then you can add it. Okay. Simply see the example. S is equal to set of 1, 2, 3, 4, 5. And into that, I want to add that element. Whenever I'm trying to add a particular element into the set, where it has been placed at the end. Okay. Next, we have remove and discard, Nana. Two operations are there. Remove and discard both will be performing the same operation. That is nothing but it will be removing a particular element which we have indicated from the particular set. But where the difference occurs is remove whenever a particular element which we are giving to remove from the set is not present in the set, then it will return a key error. Okay, when we use remove operation, using that remove operation, if we want to remove a particular element from a given set, if that particular element which we are mentioning is not present in that set, okay, then it will be returning a key error. Whereas when we are using discard, it will not return any error. Okay, whether the element is present or not, if the set is empty or not, it will not return any key error. Okay. Next is pop. What does pop do? It removes and returns any arbitrary element from S. And if that particular set is empty, if that particular set is empty, you will be getting or an error is raised. That is nothing but key error. Okay. Whenever you are using clear operation on a particular set, all the elements from that particular set will be removed. That is, the set will become empty. Okay. What does len do? Len. What does it do? You have seen it in a list as well as
It shows length of the set, ma'am.
yes, length of the set. See here, we are having a set which is consisting of 5 elements. Okay. Whenever we want to try finding the length of that particular set, it will be giving it out. Okay. So next we are having in and not in operations. What does in do? It will return true if the given element which we have given is present in the particular set S. Okay. If it is not present, then it will be giving a false statement. Okay. See this example, Nana. Here in this example is I have given 3 in S. That is the element which I am considering is 3. If whether that particular element is there or not, we need to find it now. So in set S, is the element 3 present, Nana?
Yes, ma'am.
Yes. So it will be returning present in the given set. Then it will be returning a false value. Okay. And next we are having not in operation. What does
Ma'am,
it do? Yes.
ma'am, in before slide, pop we used, na ma'am.
Yes, Nana.
If he doesn't mention anything, it should remove last element, na ma'am.
Yes, ma'am.
Yes, yes.
But here it removed first element, ma'am.
In sets, it's different, Nana. Yeah, we'll try to execute the example programs. This is just the example I have given to you. Okay.
Okay, ma'am.
Okay. I'll we'll see other examples in the lab.
Ma'am,
To
voice
know
is
it,
breaking.
not in is how about so? Here, the internet connection is unstable. Just wait for a while. I'll try to log in with. Let it be. There is disturbance outside. That is the main reason we aren't able to focus. Okay.
Okay, ma'am.
Are you able to hear? Am I audible to you people?
Yes, ma'am.
If it is not, I'll log in with another one. Yes. What's that?
Ma'am, your voice
Okay,
is
ma. See,
breaking.
wait for a while.
Okay.
Yes, ma.
Yeah, ma'am, it's okay now.
Okay, fine. So next is X not in. Okay, not in operation. What does it do? If the element which we have given is not present in the given set, then it will be returning a true. Okay. If that element is present in the given set, then it will be giving the false value. Okay. Next we are having is subset Nana. Okay. So whenever you are trying this operation, you can give that particular set name with is subset, or you can give in this manner. Here I am considering two sets, right? S and T. Okay. If I want to perform E subset on these two particular sets, you can either use S dot E subset of T or S is less than or equal to T. Okay. By using it, it returns true if every element in set S is present in set T. Okay. That is nothing but a set here, set S is consisting of how many elements? 1, 2, 3, 4, and 5. Okay. And set T is consisting of 1 to 10 elements. So obviously here we every element in set is present in T. Okay. So the return value which we'll be getting is true. Okay. If any element which is present in S is not present in T, then it will be returning a false value. Okay. Next operation is superset, Nana. Is superset, what it does is, it returns true if every element in set T is present in set S. Okay. And if it returns false if that particular elements which are present in set T are not present in set S. Okay. See the example. Are every elements of T present in set S? Elements which are present in T are every element which is present in T is present in S.
No, ma'am.
So it will return a false statement. If every element of T is present in every element of set S, then it will return a true value. Okay. Next we are having is union. Union, what it does? Let us consider two sets S and T. Okay. If we are performing union operation on it, it returns a set S that has elements from both sets S and T, Nana. Okay. Then what does intersection do? What is the operator we are using for intersection? And. Okay. So intersection, whenever you are trying to perform intersection operation in between two sets, remember that it will be returning a new set. Okay. New set that has elements which are common to both the sets S and T. Got it? In union, whenever you are performing union operation, it will update the set, Nana. Okay, it will not create new set. But here, when you are trying to use intersection, it will create a new set which consists of the elements which are common in both the sets. Okay, see this example. Here, set S is consisting of 1, 2, 3, 4, and 5. Okay, and set T consists of 1 to 10 elements. Okay, now if we are performing intersection operation on these two, we'll be getting a resultant set, new set, which consists of the intersection elements, that is common elements. What are the common elements between these two sets, Nana?
1, 2, 3, 4, 5.
Yes, that is the output which we have got. And what is the difference between intersection and intersection update? Intersection and intersection underscore update. See, intersection, it will be creating a new set which consists of the elements which are common to both the sets present. Okay, but whereas intersection underscore update, it returns a set that has elements which are common to both the sets S and T. There is a difference between intersection and intersection underscore update, Nana. Please remember. Okay, clear? Next we are having is a difference. So whenever you are trying to find the difference between two sets, what is the output you need to get? Yes, guys, are you there?
Yes, ma'am.
Okay, so tell me, what is the operator we'll be using in order to find out the difference between the sets?
Minus.
Okay, and we'll be using difference method as well. Okay, so in order to find out the difference between both the sets, whenever you are using difference method or minus operator, it will be returning a new set that has elements in set S but not in T. Okay. See, here is the example. S consists of 1 to 10, 12, and T consists of 1 to 10 elements. Now we want to find out S minus T. Here, the difference elements are stored in a new set, Nana. Okay, so the element which we'll be getting in the new set is 12. That is, set S is consisting of only 12, which is not common in both the, right? Next, difference underscore update. It returns all the elements of another set from this particular set. That is nothing but S is having how many how many numbers? What are those? 1, 2, 10, and 12. Okay, T is consisting of 1 to 10 elements. Now, if we want to find out the difference underscore update, if you want to use that particular method, what is the output? It will be returning
12.
yes. Okay. Then what does symmetric underscore difference do? It returns a new set, okay, with the elements either in S or in T, but not both.
It removes intersection element.
Yes. Okay. Intersection elements will be removed and others will be displayed. Next, copy. Copy method, it returns a copy of set S. Okay. Next is disjoint. It returns true if the two sets have a null intersection. That is nothing but we are having two sets which doesn't contain common elements between those two. Okay. Then we will say that as null intersection. Okay. And it will be returning true value if the two sets have null intersection. Okay. That is the use of disjoint. Next is all. Okay. See, Nana, what does all do? It returns true if all the elements in the set are true and false otherwise. In this particular example, y is the output which we got is false.
It is having 0, man.
Yes, in integers, we doesn't have 0, right? If we are giving 0, it comes under natural numbers. So that's the reason the output which have got is false. Okay, next we are having is any. What does any do? See, if the given set consists of any of the elements which is true, any one of the elements which is in the set is true, then it will be returning true. Else, it will be returning false if the set is empty. Okay. Next, we'll be having is enumerate. It returns an enumerate object that is nothing but it will be consisting of index and value for all the items of the set of pay. Okay. We'll be having pairs in it, which consists of index and value. Next is max method, Nana. Max operation, it returns the largest element which is present in the set, in the given set. Okay. And minimum, min returns the smallest element in the given set. Next is sum. If you want to find out the sum of all the elements which are present in the set, sum method will be used. Okay. Next is sorted. Okay. What does sort do, Nana? What is the use of it?
It arranges elements in ascending order, man.
Yes. Okay. Next one is S is equivalent to T and S is not equivalent to T. That is nothing but when the given set, two sets are equivalent to each other, it will be returning true value. Okay. And it will be returning false value if S is not equivalent to T. Okay. For next one, S is not equivalent to T. It returns true if both the sets are not equivalent and otherwise it will be returning false. Okay. So these are the operations which can be used on sets. Okay. Clear with all the operations which are present? Any doubts, Nana?
Ma'am, 1 second, explain S equal to T, ma'am.
S is equivalent to T. See here, SE is equivalent to T, right? Returns true if the two sets are equivalent. That is nothing but, see here, S is equal to, it is consisting of ABC, and T is consisting of set of ABC. Okay. So when we are comparing these particular sets, if they are equivalent, that is set of tuple ABC, if these two sets are equivalent, then it will be returning true value, Nana. If they are not, here I have given alphabets. You can give integers or any float numbers or whatever it may be. When you are comparing those two, if they are equivalent to each other, then it will be returning true value. If they are not, it will be returning false value. And coming to S not equal to T, it returns true if both the sets are not equivalent, and returns false if both are equivalent. Okay,
Okay,
Ma'am,
you
but
can
why
understand
you
these
took
better.
Z equal to?
Yes, it will be creating a new set, Nana.
Okay.
See,
ma'am,
new set. Yes, ma.
ma'am, S
No.
is S experiment is equal to T, that is not equal to T, no, ma'am. General.
Yes, not equal to T.
Okay, ma'am.
Okay, S is not equal to T and S is equivalent to T. What are
Okay.
what is the difference between these two? S equivalent to T, which if we are taking that one, it will return true if both the sets which we are comparing are equivalent. Okay.
Yes, ma'am.
Otherwise, it will be returning false. And
Yes.
S not equivalent to T, it returns true if both the sets which are present are not equivalent. It returns false if they are equivalent. Okay. Got it, Nana?
Okay. Yes.
Yes. And can anyone tell me what is the difference between sets and frozen sets? You forgot? Vinod? Is Vinod present today?
Yes, ma'am.
So, Vinod, what is the difference between sets and frozen sets, Nana? Can you
Don't
please
know,
tell
ma'am.
me the definition of set?
Ma'am.
Ma'am,
Yes.
ma'am, set is mutable, ma'am,
Okay.
and it is a
So,
collection of elements.
okay. So, then what are frozen sets?
Ma'am, they are immutable, ma'am,
Hmm.
and they initialize with element from given iterable.
Okay. See, Nana. Yes, everyone, listen here. Sets and frozen sets. These are the two concepts which I have discussed you earlier. Sets are frozen sets. Okay, these are immutable version of Python set object. Okay, in sets, the elements can be modified at any time. Okay, but here in frozen set, the once the elements are created, they will be remaining same after creation. We can't change them. Okay, due to this, frozen sets can be used as keys in dictionary or any other set. Okay, but remember one thing, like sets, these frozen sets are also not ordered. Okay, so indirectly we can say that these elements can't be set any index. Okay, so this is the syntax for the frozen set. Simply we can give frozen set of iterable. Okay, and this particular frozen set iterable is optional. You can give it or you can leave it simply. Okay, so frozen set parameters, it will be having only single parameters, that is iterable. And this particular iterable It consists of elements to initialize the frozen set with. Okay, it may be a set, it may be a dictionary, and it may be a tuple. Okay, then what is the return value for this particular frozen set? Okay, frozen set function returns an immutable frozen set initialized with the elements from the given iterable. Okay, if we don't pass any parameters, it will be returning simply a empty frozen set. Okay. Next, what are the operations we can perform on frozen set? Okay. Tell me, what are the operations we'll be performing on sets, Nana? As it is mutable, we can perform all the operations whichever are available. I have discussed previously, but on this frozen set, we can perform only limited operations as it is immutable. Okay, so some of the operations which we can perform on this frozen sets are copy, difference, intersection, symmetric difference, and union. Okay, and some of the set methods like is disjoint, is subset, and is superset. Okay, so these are the only operations which can be performed on frozen sets, Nana. Clear? Shall I show you examples? You want to see the examples for this?
Yes, ma'am.
Okay, see, I'll execute them. You just try and understand. Okay.
Ma'am, duplicate elements are allowed or not allowed, ma'am?
No. Duplicates are not available. Okay, these are avoided in sets completely. Whether it may be sets or frozen sets. Okay. See.
Ma'am, is this an example for frozen set, ma'am?
No. It's just the first one where I have told you when you are giving all, if any of the value is every value should be true. That is nothing but every value should be present in that particular list should be true, right? See here, in this example, I am taking Boolean list. Okay, in Boolean, what we'll be giving? What are the elements we'll be giving? Either we'll be giving zeros or ones, true or false. Okay, so this particular set consists of true, true, and true. So whenever I am performing all operation on this particular Boolean list, I need to, what is the resultant I need to get? True, because these are elements from Boolean list. That is the reason we'll be getting true. Understood? Guys?
Yes, ma'am.
Yes, ma'am.
Yes, got it. Shall I go to next example then?
Yes, ma'am.
Okay, see. Next is okay. See, frozen set. Okay, here see, Nana, we are considering a tuple which is consisting of ovals. Okay, so frozen set we have that consists of ovals. If we want to print that one, okay, as these are immutable, what is the output you will be getting? If we want to print frozen set is F set, that is nothing but the ovals. What is the output we will be getting? Could you please tell me why we got the error?
Ma'am, we can't add no, ma'am.
Yes, we can't add the element into a frozen set as those are immutable. So that's the reason we got this error. Okay. So remember that frozen set, as it is immutable, we can't add or update it with elements. Okay, once we have created it with some elements, it will be remaining same. We can't change. Okay, understand? Clear with
Yes.
this example what frozen set is actually? Next example. Okay, see Nana. That is the one which we have performed simply using a particular list. Okay. So here, if I want to use frozen set for a dictionary, okay, let us suppose that there is a dictionary which consists of a person's name, age, and sex. Okay. Now, if you want to print that particular frozen set, what is the output we'll be getting? Is it converted into set or not? What it did? Guys, are you concentrating on my class or not?
Yes, ma'am.
Then why is there aren't any responses from you people, and why you people are not active? Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Then okay, see, in this example, I want to convert a particular dictionary into a frozen set. Okay, so here is the dictionary which I have given, which consists of name, age, and sex. Here, name, age, and sex are the keys. John, 23, and male are, what are they?
Values.
Oh,
Okay. So when we are converting a particular dictionary into frozen set, what is the output we'll be getting? We'll be getting a frozen set which consists of the key elements. Okay. Clear,
But
Nana?
we have set answers, ma'am, for that John, that all.
No. Those are the values which you have given for a dictionary, right? But
Yes.
in frozen set, it consists, it takes the keys, that is the main ones, which are indicating the values. Keys indicates the values, right? That is, you are taking name, in that particular name key, you are giving a value to it. That's it, right? So here in frozen set, it will be considering only the keys, and they will be converted into frozen set. Okay, it will not consider the values. Done?
Yes, ma'am.
Okay. So what are the operations we'll be performing on frozen set, Nana? As I told you, we can use copy, union, intersection, difference, and symmetric difference. Okay, is joint, is subset, and is superset, right? So this is the program which will be consisting of all the operations which are performed on frozen sets. Okay, first one is copy. Here I have taken two sets, Nana, frozen sets. One is A, one is B, which is consisting of 1, 2, 3, and 4. B consists of 3, 4, 5, 6. Okay, first operation which I want to perform in this frozen set is copy. So for that one, what I have did, I copy. Whenever you want to perform copy operation, what it does?
copies the set.
Yes, copies the set. So in C, I am copying set A. Okay, and this is the output we'll be getting. Okay, next is union. In union, What is the operation? What is the syntax I told you whenever you want to perform a union operation on sets? What is the operator which we can use?
Union.
Pipe.
Yes, pipe. Okay, either we can use pipe operator or you can use union method. Okay, performing that one, you'll be getting the resultant. Next, for intersection.
And
And
Or intersection method.
intersection method.
Okay, for difference.
Minus
Minus or
Or
difference method.
difference method.
Okay, so you have got it. For symmetric difference, Nana?
Square operator. Symmetric difference operator.
that
Symmetric
one,
underscore difference.
Power.
That one. What is that one?
and
And is for
Square,
intersection,
square
no?
use చేస్తున్నాం.
Interma?
cap, ma'am.
Cap.
Yes. Okay, so remember all the operators which we'll be using in order to perform this union, intersection, difference, and symmetric underscore difference, right? So you want to see the output for this program? Okay. See. When you are performing difference on those particular sets, what is the output you are getting?
One.
What, ma'am?
Difference, Nana. I'm trying to perform difference operation on sets A and B. That is A minus B. What will be the output we'll be getting?
It will remove intersection
Yeah.
elements, and it
Intersection elements and
will
the elements. It will print only the elements of A which are
Not in
not common. Yes, which are not in B, right? So only 1 and 2 are the elements which are not in B. Okay. So that will be the output. Then how about symmetric difference?
it remove intersection elements and it will remove both
and
the
B, but not in both.
sets, ma'am.
Okay.
Including
Symmetric difference, Nana. You are talking about difference underscore update. That is different. That can't be performed here on frozen sets. Can you update a frozen set?
No, ma'am, that is immutable.
Yes, that's the reason we can't perform it. Okay, got it?
Yes.
Yes, ma'am.
Okay, so these are the mathematical operations which we can perform on frozen sets. Okay, and other operations which you can perform on this frozen sets are this one: is disjoint, is subset method, and is superset. Okay, these three methods you can use on frozen set. Can anyone tell me what are the outputs we'll be getting from these, using these methods on these particular sets? So if we are using is disjoint method on sets A and C,
True, ma'am.
True, ma'am.
why so?
Because the elements are not same, ma'am.
Okay. Next is subset. Is subset method we are implementing
Yes, ma'am.
on C and B.
True, ma'am.
How?
All the elements in C are present in B, ma'am.
Okay. Next, superset.
False.
B is
False, ma'am.
superset of C.
No, ma'am.
False, ma'am.
False. B is superset of C, Nana. Is it true or
No.
false?
False, ma'am.
not all elements present in that set.
read this one. Whenever
Yes,
you are giving superset, okay, remember that. See, C elements should be present in B,
Yes, ma'am.
right?
It's true.
They, are they present or not?
They are present.
Present, ma'am.
Yes. There is a difference between E subset and E superset, Nana. Okay. When you are giving C dot E subset of B, you'll be considering these elements which are present in B or not. Now see, you are giving B is superset of C. Then you need to see that all the elements which are present in C are present in B or not. Okay, they are present, right? So the value which we'll be getting is true. Okay, so this is about frozen sets. Are you clear, Nana, with the topic frozen sets?
Yes, ma'am.
Okay. Okay, last topic which we are having in set is set comprehensions. Uh, uh, will be what is the time?
It's already finished, ma'am. It's already 5 minutes.
Completed.
11:15, ma'am.
Okay, okay, fine. Oh, okay. This is the last topic we'll be having in sets. Okay, with this sets topic will be completed. Next, we'll be seeing about dictionary. Okay. So in tomorrow's class, I'll complete the set comprehensions and then we can go to dictionaries. Okay. And for today's lab, you can execute
Ma'am, we'll do
week
question
4
and
programs. Week 4 programs. Okay. First 2 classes, we'll be doing these programs. Okay. And last are, if you have any doubts in the question bank, you can ask me. Okay.
Okay, ma'am.
Okay, clear? Now, CR, please message me the attendance, Nana.
Okay, ma'am.
Okay? Okay, fine. Okay, guys, take care
Ma'am,
and be on time, Nana, to class. Okay, I don't accept late attendance. Please be on time. Okay? Clear?
yes, ma'am.
Okay, then. Take care. Bye.